Okay, man. All you need for this one, man. You gotta be there, man. You gotta have a guitar. You gotta have a plank, man. You gotta have something, man. It can be your dad's old guitar, man. It can be the one that's in the attic. It can be the one your sister played for a week and then it's got hidden up in the cupboard. It can be a piece of string stretched across a box. It can be anything, man. It can be anything. It could be make music, man. Music. This machine kills fascists, man. I'm getting carried away with that and my accent's actually getting worse. Oh, what do you need for this experiment? Well, anything, any stringed instrument, anything, even like a joke instrument, a toy instrument, a kid's instrument, every single one of them will work for this. Because all I'm trying to do is to prove that frequency is the inverse of length. So I want to change the length. Now you can simply change the length of a guitar string by pressing your finger onto the fan, onto the fret. I'm going to use this device called a capodastra. Now a capodastra is what a guitarist used to change the key, to hold down all the strings to one particular fret. By moving it up and down, I can do that. Now you don't have to do that. You can use your other hand, or you can get someone else to pluck the string or to put their finger down there until it's happened. Okay. The other thing I'm going to need is a tape measure for measuring the length of the string at any particular point, and a pen and paper for writing my results down. And what I'm doing is I'm making a table of frequency against length. Frequency against length. So I'm going to start by measuring the guitar string, which to the fret is 54 centimeters. So I'll write down the length as 0.54. Now, how am I going to find the frequency of that note? That's going to be the problem. God, that's out of tune. How am I going to find the frequency of that note? I'm going to use technology. I'm going to use the modern world. And to you, the modern world is always the same. It's your phone. I'm going to use my phone because I've downloaded an app called Spectroid. Spectroid is a fantastic app which has a oscillator shown on the screen. The great thing about this app is there is a second image which shows you the highest note which has happened recently. So if you bring it near the guitar and play it, it will hold that note. So you hit play the guitar string, and then hit pause, and you can see the largest note that's happened. So let's try that. I press play, and then I hold a pause. You can clearly see the number written next to the peak, and you simply transfer that number to your table, but wear your glasses, not like me. Once you've done it once, of course, it's all very easy. The next task is simply to repeat it for lots of different lengths. And remember, you measure from the fret. Look where my fingers are, from the fret to the bridge. And don't forget to start the phone again, reset it so you get rid of the red line, play it, then play it again, and pause. That's right. And then you read it off the thing and write it down. Okay, so you're writing down everything you've got, and I've even cleverly illustrated how you write down the length. There you are, write down the length and put it onto the table. Here's the table coming up. There you are, showing you just how you do it. Brilliant. All right, another one, very quickly, just quickly, shorter one. Can't get much shorter than that because you can know the bridge gets really shorter. Guitar's moving around. Cats are really playing. Anyway, ended up, this is what you see on the screen. You can see the actual figure there. Well done. At this point, the noise of the cats playing in the background became almost unbearable. So I've redone the video as voiceover. Now I'm going to try and illustrate harmonics, which this little app does perfectly. If you play a note lower than the higher notes, you'll see a harmonic. The second little spike you can see there. There's one at 313 and another at 621. The one at 621 is the harmonic. The string vibrates at both these frequencies at the same time. This is quite difficult to illustrate unless you use a strobe light. And, you know, we had a lot of epileptic fits. They took the strobe light away from me. You know the way it goes. Anyway, so now with a slightly safer way of doing it and technology, you can see this harmonic note. Now, it's not the only harmonic. There's many harmonics and they decrease. You can just see the edge of the other harmonic on the screen on the far right. This was when I was playing the note G. So if you play lower notes, you get extra harmonics. Now the string has the ability to vibrate at all these different frequencies at the same time. So if we look at another one of these vibrations, you can see here, there are in fact 3 on this one. This was the playing D on the guitar. And as you expand the range, you'll be able to see even more of these harmonics. Now we have to draw the graph. So this is the table I just got from the experiment on the guitar, showing the frequency against length. The frequency is in hertz, and I marked this on the table with the length, which is in meters. I've converted it from centimeters. I was going to write centimeters and I write meters, which is why the M looks so funny. Now, if I was to plot it just exactly like this, I would get a graph of F against L, which would look like that. Now, that is of no use at all. The reason it's not a straight line through the origin is that F is not exactly proportional to L. There's some other relationship. Some relationship we have to discover. Now, of course, I could take you through thousands of variations, but I know what the relationship is because in the logbook, we have the formula F is equal to 1 over 2L square root of T over mu. And the only 2 letters we seem to be interested in are F and L. And so I can see that F is proportional to 1 over L. So I'm now going to make a table of 1 over L. So all the values are exchanged into their reciprocals to get me the relationship I need so I can plot a graph of F against 1 over L, and I should get a straight line which proves the 2 of them are proportional. So that's what I'm now going to do. So now I have my full table of values. I'm going to plot frequency against 1 over length. So the lengths are now no longer in use. I'm now simply plotting frequency against 1 over length on this piece of graph paper. Of course, I'm going to draw in the lines, work out the maximums. Well, the biggest values are probably going to be the same. So there we are, 2.5. So I'm going to put length against here for 2.5, 1, 2, 2.5. And I'm going to put frequency up here, again, starting from 0, even though there's no value near 0. So we'll have 100, 200, 300, 400, 500 going up the side. Now we have all the points plotted. We only have to draw a straight line between the points to prove the relationship between F and 1 over L. Now we always start at the origin, and the aim is to get half the points on one side of the line and the other half on the other side of the line. So we're drawing between the points as much as is possible. Even though none of the points are particularly close to the origin, this actually gives a very good correlation of the graph. Now, because we have a good graph, which goes through the origin and which is a straight line, we can definitively now say that this proves that frequency is proportional to 1 over L because, and this is the big thing, we have a straight line through the origin. The origin. There we go. And that, of course, is the origin I'm talking about. Now, anything you can get a straight line for proves what's on the y-axis is proportional to what's on the x-axis. The two things are proportional if it's a straight line through the origin, and that's physics. So we have the table, we've transferred them to the graph, we have a straight line. That's what you have to do. Now, of course, I'd rather you did the actual experiment, downloaded the app, had a go at the guitar. But if you're terminally incapable of getting out of the chair, you can, of course, just use the table I'm going to provide. But then you have to do the whole question instead of just the graph. If you're doing the experiment, you just do the graph. If you're not doing the experiment, I want you to do the whole question, which I've set. Simples. Just one more thing. Okay. Rock on, man. Rock on.